Hello everyone, welcome back. Today we are going to learn about a package called Pydeck, and we are going to visualize geospatial data in 3 dimensions. So stay tuned and let me just share my screen very quickly. So welcome back. Now here we are at my Python coding terminal, which by now you are probably very much familiar with. So first of all, in this video I would like to show you how to use Pydeck to create 3-dimensional geospatial visualizations, for which we will need 3-dimensional geospatial data. For that, I'm going to introduce you to a really great website called Budapest Open Data Atlas, which is created and run and operated by the data visualization and data journalism team ATLO from Budapest. And for now, as far as I know, the website is only in Hungarian, so I'm going to be translating, and you probably will be learning a little bit of Hungarian. So here we are going to look for a data set and the map which is showing us the building height distribution across the city, which essentially means that we have a building footprint geospatial file which is 2-dimensional, and for each building we should have a float number attached which is describing the building height in whatever units, hopefully for instance in meters. So as I tricky word again. So as I keep scrolling down, I will arrive to one called épületmagasság. So this one here, which stands for building heights. It is sourced from the Copernicus Urban Atlas, and here there is a link to a GeoJSON file which you should just click on, and the download will start very soon. So here you get redirected to this Google Drive, and if you hit download, then you will have your file downloaded. So that's what we will need, and that's what I also should double check if I have in my directory. So let me just see if I have done my homework well and if I have downloaded the right file. So meanwhile you are downloading your file, I'm going to check my environment. So it should be somewhere here, and I've actually recorded this video once before and then I got stuck because I couldn't find the file and where I downloaded it. So now I'm trying to not to make that mistake again. Yes, it's here. Almost sure it's here. So let me just got this new notebook here, Pydeck with file. That's a very fitting name. And let me just put it full screen. And maybe should zoom in a little bit as well. Okay, so here we are. Now we are ready to go. So the first thing we'll need is to ignore warnings. This is happening because I'm going to import now a GeoPandas version, which is not the latest, and that's why it's giving all sorts of errors. So this is still a homework for me to do to upgrade everything to GeoPandas version 1.0.1. But anyways, things will run perfectly there as well. Just a few things in my previous projects that I have to update, and I was probably just lazy or too busy to do that. Anyways, now we can start reading the file, which once you download will be called épületmagasság.geojson. Okay, the reader is working, so the file is nearby. It will take a while because it's a huge file. In fact, it contains more than 350,000 footprints across the city, which is going to cause us some trouble, so that's also an opportunity for us to learn how to filter large geospatial data files. I will also, once the reading is done, we will see how many records we have there, and I will show you how to just plot a smaller sample by taking 1,000 random records. As you can see, more than 350K. So if I just take a small sample of 100 records from this geodata frame, now you can also take a look at the geodata frame. See, we have all sorts of parameters. dn is the one we are looking for, that's the building height, and the geometries, which are the footprints. So now let's just plot one element. This should be just one building. As you can see, it really looks like a building footprint. It has corners and stuff like that. If we pick two random samples, then we don't see much. It's because we have here on the upper right corner and here in the bottom left corner one tiny building footprints. If we try to plot 1,000 building footprints, now we can see that there are some tiny dots here. And if we add one more zero here, then we kind of see, especially if we have seen Budapest before, that now kind of Budapest is getting outlined. So that's a good start. We have something very exciting here. So now I will import one of my favorite libraries, OSMNX. And the reason is that I would like to filter down this map of Budapest to a smaller section, for instance, to one of the districts like District 5, which is actually historical downtown. So let's call it admin. And I will use the geocode to GDF function, which takes the name of a place and turns that into a geodata frame. And since I added District 5 of Budapest, I will get exactly that, which you can see here on the map. The next step is to filter this original large geodata frame called GDF. And let's call it GDF2, and we can do the filtering by just saying that we want to overlay the original geodata frame by this small admin polygon here. And we can also print the length of this new geodata frame as well as the old one. As you can see, out of the 352,000 footprints, now we only have about 8,000. So that's something much smaller, much easier to manage on a laptop. Now we can also plot it. We will see the outline of the district, as you can see it here very nicely. And we can also see that it's much smaller, and it took just a few seconds to draw this plot. First, let's just create a quick two-dimensional visual with Matplotlib. I will create my canvas here. This measures in inches, by the way, so 10 inches, which is probably a bit too much here, but never mind. And we can use a color map like reds, and the column to plot the building height, which is dn. So now we will see the largest, tallest buildings here, for instance, a tower on the Parliament. Yeah, and the Basilica here. Okay, so now we have this new filtered footprint data. Now let's go for the three-dimensional visual, for which I'm going to use the library called Pydeck. I import it as PDK. So the way Pydeck works is that first we need to define a layer that we want to visualize, and here it's kind of leaning towards the underlying JavaScript coding because the syntax is a lot more like that instead of Python. So this is going to be a polygon layer. As the data source, we will use GDF2. We have to tell where to get the geometry information, which is coming from the geometry coordinates, part of the geodata frame. We have to set the extruded parameter true, which should make this three-dimensional, and the elevation parameter sets which column should be used for that. And we can define a filling color for the three-dimensional building models, which will be, I think that this will be red in the RGB terminology, just using square brackets. Okay. And we also need a view state, which takes a couple of parameters which we will tweak later on, but for now the basic ones are the center of the map, which will be in the center of Budapest. And yeah, I have notes on the other screen up there. I don't know these coordinates by heart, so don't worry. Longitude. So much typing. I hope that I will make no typos here, but no guarantees. And we can also specify the initial zoom level. It should be like 13. Okay, and now it's time for Pydeck to do its magic. For some reason, they usually call these maps R. I'm not yet sure why. We have to define the layers. So here we can add actually multiple data files, so multiple data layers. and we can define the initial view state. And then just show the map. Here we are missing a column, but other than that, it seems that it's working. So now we should debug the code further. So it's just one layer. Yep, I just said layers out loud, so that's why I type layer. Okay, so now it's rendering. We should be on the way to get a nice visual very, very soon. Yeah, okay, so here there was a cut in the video because for some reason I had to restart my kernel because this picture was not displayed. So now here it is, it's already interactive, so we can zoom in and you can see that these are indeed three-dimensional building models which have the height of the DN value and which have a shape of their building footprint. So that's cool. Now let's see how we can make this even nicer. So let me just copy this code first. And let me pick a few things to change and modify here. For instance, let me play around with a parameter called pitch, which controls the angle of the camera relative to the ground. And we can also set or change the bearing, which is again one visual parameter, which controls the rotation of the camera around the vertical axis, if I'm correct. And what else? Maybe we can zoom in even more, and let's see how this will look. Maybe we can also set, for example, the line color, which is a color that goes to the edge of the polygons, and see how this map will look like. Okay, it might take a few seconds to re-render the map, but now here it is. Now you can see the building map of Budapest. And now that we changed the camera view settings, you can see that the three-dimensionality is actually much better, much more visible here. Okay, so that's nice. There is one last thing I want to show you though, is how to use a color that gradiently changes based on the height of the building. For that I will use the math function, and I will create a variable that is called scaled, and I will use that in the fill color parameter, just like this. And so this scaled parameter should be between 0 and 1, so that we will have a color which is changing from the 255.00 to 255.0255. And for that I will need to renormalize this dataset. And I will call this variable scaled. And let's add a random constant so that it's kind of shifted from 0, so it's actually not starting at 0 but near to it, plus. So let's do the renormalization. And hopefully there are no bugs here either, and this will run effortlessly. So now what we should get is a three-dimensional building map where each building is colored in a gradient way, going from red to purple, or pink to purple, or okay, maybe I'm not that great in like naming colors, but you know what I mean. This is not super red. And here we can see the tallest buildings, the basilica, and the parliament. So, oh yeah, this is better this way. So yeah, actually that was it for today. So thank you very much for watching, and I hope you enjoyed learning how to create three-dimensional maps in Python with Pydeck and with me. So let me know how it goes, and let me know if you can reproduce the map without any issues. Stay tuned. Bye.